What is going on, guys? Welcome back to the next video in learning Kotlin. Well, actually, welcome to the first video in learning object-oriented Kotlin. I congratulate you guys if you guys are making this far. So it's time for us to start a new chapter, and this new chapter is object-oriented programming. If this sounds very foreign to you guys need to be aware that when you guys do the function and function overloading, when you guys get experts inside the function in Kotlin, the next step is that you guys needs to be expert into the OOP, or in short, we write this OOP, or in reality is object-oriented programming. Okay, so we abbreviate this as like a OOP, but it's object-oriented programming in full. What is actually this object-oriented programming? Okay, so we try to explain this within say 15 to 20 minutes. If it gets more than 15 or 20 minutes, then I'm gonna cut off the video and I'm gonna make it say first part or second part, so just keep in mind. Okay, so we begin with OOP. OOP is a way to decompose or break a big problem into small pieces and then solve the small pieces. So as it says, it's very easy to understand. Object-oriented programming is a way to decompose our you guys can say to break up a big problem, a very big massive problem, into small pieces. So that's the one part you guys need to understand, and then solve this. So I'll put SESE, and then solve these small pieces. So each chunk, our small pieces, is self-contained and reusable. So you can say self-contained code. So each chunks, our small pieces, whatever it is self-contained code and is very reusable by other programs or classes. And we call these small chunks as objects. So we gotta say big problem, say we want to solve, and we decompose it, or we break it up in small pieces, and these small pieces are self-contained code and they're all very reusable by other classes. And then we call these small chunks or small pieces, we call them objects. When we plan and design these objects, we do it with classes. So these objects, now we have these objects, and how we're gonna create this object, we do it with the classes. So in short, a class is a blueprint of an object. When we implement an object of a class, we call it instance of the class. Say object, by object, the simple definition of the object is a thing. As a thing, it's a real world. With the OOP, we go and model, computer models the real world objects. How the computer models, we give their computer data. Say anything is object. Motorbike is object. Say car is object. Human self is objects. A dog, a cat, popular ones is a car, airplane. Anything that has a property is objects. So objects are things. Anything you guys can see, you guys got a property, it can run, it can go fast, or it has a function, it slows down, brakes, whatever, is objects. So objects, in short, objects are things. So but in computer, because we are computer programmers, we get a big problem and we solve, we divide this problem in small pieces, in small chunks. Then we call these chunks as objects because they are self-contained, and they can be reused by other classes or by other codes in our program. And we plan and design these objects, and we do that. How we gonna plan with design? We do it with objects, just like an architect who works on the road, building our apartment, whatever is working. So they design this say a building, a big building, our road, our bridge, or whatever they design that one. And when they design and everyone looks at the design, and they build the bridge. We are exactly working the same because we are engineers. We're making software. We are in virtual world. We're making software for the computer, and we have to just like an architect, we have to go there and design and for our blueprint. And what is that blueprint is called? It's called class. So object is the how, if someone gonna ask you what is object, and you guys gonna say that object is we call it instance of the class. Okay, now we're gonna come towards the Kotlin object-oriented programming, because this our folder which is in our playlist is Kotlin object-oriented programming. everything is in Kotlin is associated with classes and objects. So keep in mind that whatever you guys are going to see, all these classes, whatever you see is associated with classes and objects along with its properties and functions. And say for example, the bus has a property such as a brand, color, and weight. So the bus, or as I said to you, the motorbike, our car, whatever you guys can see, is all of them has a properties. A dog, our cat, you guys can see the dog, cat got a say color. They can have other properties like legs, 4 legs. They can they say meow, or dog, whatever, they make bark or they say meow. That's a property, and the bus is no exception. The bus is object, it's a thing, and it has a property such as brand, color, weight, whatever you guys see. It's got a wiper, it's got a say writing on side on there, it's got a windscreen, whatever you guys gonna see is a property. And functions such as accelerate or brake or slowing down. Say our bus has, when it's accelerate it goes fast, and when it brakes it slows down. So it's a function inside the bus. Okay, now we're gonna come here, and because now we know that what is objects. Objects are real world things. A real world, say objects is in plain English, objects means something, or a thing. So in short, but this is the easiest explanation I can give you. So objects are real world things, and we provided, so as I said before, we provide the data to computer, and computer model our desired objects. So if we provide the data of, because the computer by itself, they don't have brain, they do not think, or they do not make model unless we as a programmer needs to give the computer the data, and the computer models this for us. Say if I give the computer a dog or cat, the computer's got no idea, because I'm the one who giving the computer data. I'm the one who telling the computer, look, this is the data about the bus, and I'm going to give some properties for the bus, says the brand or color, whatever. Then the computer models that one, and that model calls object, a thing. We use objects to identify things in the real world. Objects are modules of functionality and can be used again and again. So once we create objects, it's a module of functionality and can be used again and again. And in programming we say try, do not repeat yourself, and because you guys going to write as a programmer thousands and millions of code, and every time if you guys want to repeat yourself, then good luck. And then the programmers coming with the idea of the object-oriented programming, and now that objects are module of functionality and can be used again and again. Instead of writing for about that code again and again and again, you guys can just simply instantiate that one, and you can use that one. And we're going to go on the instantiation soon. Now we're going to come on a state, and objects has a state, and it describes its characteristics. Each object handles the task it performs. And then we're going to come in the property, because the state of the object consists of a set of properties. Properties are element of the state. So as we say in our functions, just like a functions, but because we said methods, because we declare it inside the class, and once you guys declare function inside the class, you guys need to call it method, or in C++ we call it member functions. So member functions or methods inside is a way for us to access the objects, so we can instantiate this object inside the methods. So say if we've seen our functions before, so we say for example a break, and that's a method. Say if you guys come here and says accelerate, and that's also a method, and through this method, through this one, you guys gonna come and see, you guys can instantiate these objects, you guys can use these objects, and you guys can access these objects. So then we're gonna go on say class. What is a class? If you guys hear this class, it's the main component inside the object-oriented programming, because when the C++ coming out of the C, and we used to call this C with classes. That's the reason the C++ is differentiated from C. Is you guys going to see the 2 plus plus, it means that incrementation of the C, and the only difference between the C++ and C is because C++ has a classes and it has an object oriented programming, while the C by itself is just procedural programming. Okay, so the class is a blueprint. As I said, as I explained to you guys before, architects, he or she draws the map of the bridge, or he draws the map of the, say, a road or a building, big tall buildings, and everyone looks at this blueprint or map. They're going to make up this beautiful bridge or beautiful building. Same as the engineers working inside the car in a car factory. They design the car's body, the car's say how big, how powerful should the car be, how large or how small, what type. It should be sedan, or should be hatchback, or station wagon, or it should be bus, or it should be any other vehicle. So they make a blueprint, and through this blueprint then they make the object. Say a car is an object, a bus, a motorbike, whatever is object, and of some kind, whatever kind they want. So but in a programming we say class is a blueprint, and through this class we create the objects. It defines what our objects will look like once it's created. It defines properties and methods. So the class defines properties and the class defines methods. So an instance of the class represents exactly one object belonging to the class. Instantiation is the process of creating objects from the class. As I said to you guys before, we create the objects from the class through instantiation. So when we instantiate, we create the objects from the class. Then we're going to come here, a constructor. Constructor is like constructing a building, or constructing a bridge, or constructing a car. Just like exactly like that. We are builders, as I said to you guys before, and we build software. As architect draws the, say, our plan a building. The process of initializing or creating an instance from a class is called construction. So by default, if you guys create a class and if you guys don't put your constructor, the Kotlin creates a constructor behind the scenes. So if you don't put a constructor, without a construction, it's impossible for you guys to initialize or create instance from the class. So it's impossible. Then if you guys don't put your constructor, then the Kotlin or any other Java or C++, whatever programming language you guys using, they're going to create behind the scene by default. And keep in mind, there are more than one constructor inside the class. There can be two constructors inside the class. So even if one of them is default and another one you guys create by your own, you can overload the constructor as well. Keep in mind, encapsulation is also called data hiding. So in C++, if you guys done that one, we hide our data. We hide encapsulate our data, because we are not gonna hide our data from hackers, or we are not gonna hide our say data from say bad guys, or say thieves, or ATM say gonna come in and look at your code. No, we're gonna hide our data from other codes, from other classes, and from other functions. So and say if you guys gonna create some variables inside your class, and say that variable is gonna be say about the bus, about the brand and color, and see if the color is red or the weight is such and such, and whatever the variables you guys create, then you guys gonna create another class with say car. And you guys, the reason you guys gonna hide your data is because just innocent mistake, you guys don't use this variable again in another class. That's it. That's this process called encapsulation, because you for program for you guys not to make innocent mistakes. So once you guys, if you guys make a small mistake and you guys go ahead, then you guys your program is gonna be buggy, then it's gonna crash, because you guys using this variable so in many classes, and you can access your variable through that say a class. You guys still can use your variable from say from the class. If you guys declare that one is private, you guys still do that, but there's a long way, and the Kotlin makes sure that you guys don't make a mistake. So this process of the hiding your data is called encapsulation. We keep internal working of our code safe from the other codes, classes or functions. So what we mean by other codes, we are not meaning by say codes, not hackers. Say, as I said to you guys, we are not hiding our data from say ATM hackers or thieves, because they can't steal our codes. Okay, it's just a code. We are hiding our code from other codes. Say, and that one is going to be, say, for example, classes or functions. So they can come in here and access this code of this class. And now allowing by this process, we are going to allowing only authorized code to use this variable, whatever. And then you guys going to come in object-oriented programming. You guys going to come in at polymorphism. Polymorphism is very confusing for a lot of people. It's a Greek word, and just simply poly is meaning many. Just keep in mind, poly means many, and morph means forms, and in short it means many forms. So keep in mind, polymorphism is a Greek word. Poly means many and morph means forms. Just like a polynomials, poly means many and nomials means variable, number, whatever you guys think of, that's nomials. So here in a programming as well, so poly means many and morph means many forms, and it means many forms. Say you guys are gonna say there, and you guys we have in English many there. So with one there, if you guys think, you guys means a lot. So means a lot, and you guys are gonna refer to many things, many forms in just say one word or three words in English. Say there, and you guys just spell it. It's a little bit different, but it means a lot in every say context. It means in different contexts. And so polymorphism implies many forms in many ways. It allows code to be contextual, just like the way we say in English. It is the concept with the help of which single action in different ways can be performed. So one single action, as I said to you guys before, there, or they're happy, or they're smiling, or they're hard worker, they're gone, whatever you guys means a lot. And with this one, with one single action, you guys want to say different ways can be performed. So different ways with one single action can be performed, and by that we say two ways of polymorphism. There is two ways, keep in mind. The first one is a compile time polymorphism done by method overloading. We've seen the function overloading, and you guys gonna know the function overloading, and that's exactly a way of polymorphism. Say you guys are gonna create the function overloading, and this guy is here, and that's a one-way compile because we are overloading our function. So overloading means that with one function we have created many forms. So with one Corio, say a wood, we just change the parameter and it becomes like a 4 of say same that we name it wood, and we just change the parameter, and just like this of kind of polymorphism, we have done some sort of polymorphism. And the second one is runtime polymorphism, method overriding, and then we're going to go on when we start classes and object-oriented programming, then we're going to explain this part as well, but this part you guys shouldn't have any problem with. And the last one in object-oriented programming is inheritance. It means inherit. We inherit from our fathers, our grandparents, whatever they have. We inherit our color, our height, whatever we have, because it's very easy to know. We inherit something means inherit. In our programming, it is the basic feature of OOP, object-oriented programming. We use it to create a new data structure based on the old ones. So this is called inheritance. And in the next video we're going to go on coding, how we're going to create a class, a simple class inside Kotlin. Alright guys, that's it for this video of this object-oriented programming in Kotlin, and I'll see you guys in the next video, and bye.